Welcome to the Engineering Update. I'm Janine Mooney, Editor-in-Chief of WDD. In this week's episode, Self-Destructing Air Delivery Vehicles, Europe's first trip to Mercury, and solar-powered cars race 1,900 miles. In the past, DARPA developed self-destructing electronics in an effort to prevent advanced military gear from falling into the wrong hands. Now they're expanding the idea with their inbound controlled air releasable unrecoverable systems program, also known as Icarus, which will develop small, unmanned, single-use, unpowered air vehicles that can be dropped from an aircraft to deliver supplies in remote locations, and then evaporate into thin air once the job is done. Icarus, named after the mythical character who flew using wings made of feathers and wax, but fell to the earth when he soared too close to the sun and his wings melted, evolved from DARPA's Vanishing Programmable Resources program. The Vapor program is developing a new class of self-destructing electronics designed to destroy themselves on command, to prevent them from being captured by enemy forces. The air delivery vehicles will need to meet certain criteria. These include the ability to drop payloads of up to 3 pounds within 33 feet of a target landing spot and cover a lateral distance of over 93 miles when released from a stationary balloon at 35,000 feet. The vehicles must also completely vanish within 4 hours of delivering their payload during the day or within 30 minutes of morning civil twilight if dropped at night. Icarus has a wide range of applications, from delivering food, medicines, water, and other supplies to remote communities that have been struck by natural disasters or epidemics, as well as for supporting military units in the field. The delivery vehicles would carry out their tasks, then evaporate or crumble into dust, preventing sophisticated technologies from falling into the wrong hands, and would also reduce cost as well as environmental and logistical problems by eliminating the need to disassemble the craft and haul them home again. Icarus is a 2-phase program scheduled to last 26 months.
In the US, the news tends to focus on Mars and the Moon a lot, but the European Space Agency, with the help of the Japan Aerospace Exploration Agency, has set their sights on a different planet. The mission, called Bepi Colombo, is Europe's first mission to Mercury. Not much is known about the planet, which is the solar system's smallest and also closest to the Sun, with an orbital period of just 88 Earth days. The mission, originally scheduled to launch on July 16, has recently been pushed to January 2017. It's scheduled to arrive in January of 2024, with a planned 1-year mission and potential for a 1-year extension. 2 spacecraft will make the journey, the Mercury Planetary Orbiter and the Mercury Magnetospheric Orbiter, as well as the carrier spacecraft, the Mercury Transfer Module. The spacecraft will use a low-thrust electric propulsion system to steadily propel itself in a series of arcs around the Sun. The mission includes 8 planetary flybys, including 2 encounters with Venus. The 11 onboard instruments will focus on Mercury's surface and internal composition, as well as high-res imaging, surface composition, searching for water ice, and looking at the planet's exosphere. The researchers are hoping to understand more about Mercury as a planet and how Earth and other planets formed.
The World Solar Challenge kicks off this Sunday and will bring together 50 teams worldwide to race their solar-powered cars against one another in the Australian outback. The race spans just short of 1,900 miles from Darwin to Adelaide. Of the 50 teams, 7 are from the US, including MIT and Stanford University. The objective of this competition is to promote research on solar-powered cars. Since the cost of panels has significantly dropped in recent years, solar power has proved to be a viable source of alternative energy. Judges of the competition are looking for the most efficient and drivable vehicles. The competition limits cars to no more than 5 kilowatt-hours of energy storage. The rest of the vehicle's power must come from solar energy generated while out in the sun-scorched field. Most of the cars don't look like those you see on the highways. Stanford team has solar panels all along the hood, and the driver sits close to the ground in a plastic bubble mounted on one side of the chassis. This won't be an easy ride. Drivers will be challenged navigating the rough terrain of Australia's desert, as well as surviving nearly 2,000 miles without plugging in. It's sure to make for an exciting race, but hopefully this competition will teach us a thing or two about solar-powered cars. In the meantime, we still have a ways to go with electric vehicles.
That's all for this week's video. Be sure to check in on Facebook and Twitter and view past episodes on ecnmag.com. For the ECN channel, I'm the Donut Man. And this has been your Engineering Update.
Are you even here, John?
Icarus.
Icarus.
No.
Yes.
Is it Icarus?
Yes.
I was actually saying it at my desk. I'm like, because it's like named after some.
Icarus.
Thank God John knows. Did you know that?
Plastic bubble mounted on one side of the chassis. Is that it? Chassis?
Chassis.
Chassis